So there is an additional concept here called Lambda at edge. So you have your edge locations. When we talk about CloudFront, we talked about edge locations. Edge locations are all over the globe. And so you use CloudFront when you need performance by caching the frequently requested resources at your edge locations. Edge locations are closer to your real users. Your users are all over the globe, and they don't have to go to the real source. First, it will always find out in your edge location to see if I have a cached copy here. If not, then I'll go to the origin servers and get it and cache it. Right? That's the concept of edge locations. And right, we talked about it, the edge locations, when we talked about content delivery network, CDN. Now there is a newer concept here called edge computing. So edge computing is that you can do your compute closer to your end users. That is edge computing. So if you deploy your Lambda function somewhere in Ohio, and a guy from Sydney is trying to access something, okay, that's required from that Lambda function, and then he will have to come all the way to Ohio from Sydney, and then Lambda function will be invoked and the results will be sent back to Sydney. That's a typical Lambda. But Lambda at edge is the Lambda functions like exactly how your static resources are cached at your edge location. Your Lambda functions will be cached at the edge locations. So in this example, when a Sydney guy tries to invoke that Lambda function, then that Lambda function will be invoked at the edge location closest to him. And of course, that Lambda function, if it relies on some S3 or something, it will go across it. But the beauty here is that you will be using Amazon's own networking rather than using your regular backbone internet. Right? You're using Amazon's own networking. So edge computing is push the computing services to the edge, meaning to edge locations, so that this computing happens closer to where your users are. That is Lambda at edge. That was introduced a couple of years ago. And that's a Lambda at edge. You will be able to deploy. Actually, when you created a Lambda function, API gateway, when you talked about API gateway, it will give you options, regional or Lambda edge or something. So yeah, so essentially you will be able to deploy the Lambda functions to the edge location so that you will get much more performance. You are not going all over the globe. Okay, that's a Lambda at edge. It's all about edge computing. When you hear edge computing, that's what it is. The concept-wise edge computing, meaning you want to do it as closer as possible. So, for example, your tractor sensors. Your tractor sensors are in your factory. There are multiple machines out there, and there are thousands of sensors for each big machine. And then they all emit a lot of events, and all the events you are using something like streaming service like Kinesis, putting it and sending it to some far location, and that's where all the computing happens and come back. Not really, you don't need to do that. Rather, push that computing to the edge itself. Make the decisions as closer to your real users as possible. Run the compute engine as closer to your users as possible, and make the decisions as closer to users as possible. Make sense?
So
That's a
basically, the Lambda function will be in the region which we created, but it's just that it pushes the cached content to the nearest edge location of the client who is like trying to access it.
yeah,
Compute.
yep, yep,
Okay.
yep, yep.
Okay. Got
It
it.
will be pushed
And
to all the edge locations. Yep.
sure, got it. And one last question, Venkat. Sorry.
Oh no.
Yeah. So there's a concept like creating alias, and there is another option I also saw, like in the qualifiers, they can switch versions / aliases. So what is the aliases and what is I think you already mentioned it's already having versions, right? So what's the difference and where do we use the alias?
The alias, I will have to take a look at yeah, qualifiers. It's version / alias. What's the okay?
Yeah, in the actions, if you see, there is option to create alias and also publish new version. But here in the qualifiers, we see switch versions and aliases, and it has some filtering. I don't know what's the purpose of this one.
Right, right, right. Let me look at it and get back to you. Yeah.
Yeah, sure, Venkat.
Let
Thank you.
me take a look at it. Yep. This is unqualified. Okay. Give it to me. I can take that. Yeah, that's about it. So now the point is, I want you to, especially these lambdas, I want you to be as comfortable as possible. Again, this is one of those things that not for the exam. You know, my promise to you guys is that I'm not exclusively for exam. It's I want to make you guys real architects. So I want you to really play with it and appreciate it. Then you'll be able to appreciate API gateway better. So we'll combine a couple of things tomorrow. API gateway.
Venkat, I do have a couple of questions. I mean, when you end it, I wanted to ask those questions. Now, Lambda is an event, right? You can use multiple events in Lambda. Okay. Instead of creating multiple Lambdas, can we create one Lambda and try to trigger multiple points?
Let me see if I understand it right. First of all, Lambda is a computing service.
Computing service.
It's a piece of code that's running somewhere, right?
Yeah.
So now this Lambda can be triggered by 10 events.
Yeah, that's what I would.
The Lambda can be triggered by 10 events. So I want my Lambda function to be triggered when an S3.
Let's take your weather example itself. Okay.
Go ahead.
Weather example, you have a S3 bucket where you have a CSV file that you have saved. You trigger a Lambda function as soon as the CSV file is put over there. Now, can we take that and put it in an API where we created a web services and we have linked that data to a web services where it has to host it?
Yep.
So one Lambda function can be used to do it, or we have to
write. Okay. I understand now what you're saying. So what you're saying is that, okay. So now the monolith mindset versus your single responsibility principle. Lambda is supposed to follow, and all of your microservices, for example, right? It's kind of a microservice architecture. In your microservices architecture, one of the object-oriented principles that Uncle Bob, Robert C. Martin, has laid out in his book, The Clean Code, right, is single responsibility principle. So these are SOLID object. If you guys are familiar with it, solid design principles, right?
But you said it also is event-based, right?
Yeah,
event triggers.
Absolutely. No, I'm getting there.
Sure.
So this is I'm kind of going off tangent, but this is a very important design principles, right? The first one is a single responsibility principle. Single responsibility principle says that you do one thing and one thing very well. That's exactly what your microservice architecture should do it also. So your microservice, you don't want to, you have your boundary context. That's what they call it in microservice architecture. Okay, you define your boundary and you don't want to do 10 things. Do one thing, do well. So now let's talk about, let's bring, I put the stage, I set the stage for the conversation. Now let's come to your question. So I have a Lambda function. So one way to design it is, I have a Lambda function that will parse the data and load it into my database tables. I have another Lambda function. This Lambda function's responsibility is to read the data and pass it on to my API gateway so that my API gateway will expose it as a HTTP endpoint. So your question is, can I combine both of them? So one thing I want you to understand is, one, it's not a monolithic, your web application. It is a simple function, a finite function, a simple function. Function by nature means it does only one thing. Well, can I not do that? Absolutely, you can mess with it and do it in such a way that you have the event, you have the context based on the event. You can go to the event and then say, what event, by the way? Is it an S3 event that got triggered or an API gateway event that got triggered? Sure, if it's an S3 event, okay, I understand the same Lambda. Now, what is the bucket name and object key? Okay, let me go get it and store it into the database. Okay, is it an API event? Okay, if it's an API event, my responsibility is to echo back the response for the zip code that's given. My responsibility is now API provider. You see what I'm saying? You can, like your if-else conditions, like how you do it. Absolutely, you can do it. But is that the recommended approach? Absolutely not. So you are now muddying, it's kind of everywhere. Your responsibility segregation is not there. Are you able to appreciate what I...
Yeah, Venkat, I understand. But means I was thinking from the complex perspective of whether we can do it or not.
Oh, absolutely. Because the sheer nature of this guy here, right? You have your event. You have your event itself as one of the inputs, right?
What triggered my question is, you said a container. A container we can have multiple containers, right? That's what Amazon says. You have multiple containers and Dockers.
Sure. Okay.
So if Lambda is a container, I can have multiple.
Lambda is not I'm sorry. Lambda is an executable piece of code that will be deployed in a lightweight container.
Lightweight. Okay.
Understand that first.
Okay.
So meaning this is a piece of Java code. It's your jar. It's your jar file, right? So what Lambda does behind the scenes, AWS does, is that it creates a simple all the Java based applications. It will put it in a let's say one virtual machine. Okay, this one virtual machine can have 1,000 containers. Okay, they all share one host operating system under the hood. Okay, but they all have multiple runtime. They all have a kind of a single runtime environment, meaning each one of them has their own runtime environment. Each one of them has their own JVM. Each one of them they have their own listening ports, etc., etc. But under the hood, they carry the same operating system. That is the shift between virtual machine and container.
Sure, understood.
First of all, is that fair? Did you understand that?
Yeah.
So now let me give you more information there. So what happens is, when a Lambda gets triggered, your AWS will check. Hey, do I have a running container right now who I can give this request to? No. To start with, no. So what it does is, it will spin up a new container, deploy a piece of code into the new container, okay? And then it's in fully warm state. Now it gives the request to you. It will call that handle method, handle function. Okay. Now, after, I think it keeps in that warm state for some time. After your response is given back within the period, let's say it keeps it for 5 minutes, that container. Okay. Within the 5 minutes, if there is one more request coming in, okay, your container is already in warm state. It will give that request to that guy. If not, your container will be destroyed. Now, let's say the second request came in after 1 hour. Now a brand new container will be created, your code will be deployed, and then your invocation will happen. So the interesting point here is that I try to understand what I said there. Maybe I'll pause for a minute there, because there is an interesting consideration there for performance. You may be asking that, okay, if we are talking about, I understand the container is so lightweight, but still creating a container, deploying my piece of code, and then handling it, handing it over to that, handing my request over to that, isn't it little slow? Agree with you, absolutely. So that's why there are some strategies out there within Lambdas that to keep them in a warm state. What we do is sometimes we will do a health check. So we make, in the background, we'll make fake calls so that your container will be running within that. Then maybe you may be asking that question. Okay, then if you always keep it running, then what's the difference between EC2 and this one? Absolutely, there is a world of difference between EC2 and this one. This is a very, very, very lightweight container. And number two, you are not maintaining the container orchestration. You can have maybe 1 or 2 containers always running in that warm state, so that they are always ready to take the requests. But it's not like you have your big big V12 truck ready, always running, ready to take your request. That is your EC2 instance. You don't have it. You don't need it. Does it make sense? So it's balancing between those two, trade-off between those concepts. First of all, you asked something, I went all over. Does it make sense?
Sure. Okay, understood.
Yeah.
Now, I do have another question. As an architect, okay, as an architect, when do you decide? I understand EC2, for me, Lambda and EC2 seems to be the same function. Okay, but yes, as you stated, Lambda acts differently and EC2 acts differently.
When do I choose what?
Yeah, that's where I was coming. When do I choose what?
Yeah.
Because I can put my code somewhere else and I can use Lambda to pull that information, which also saves cost for the client. For example, how do I say it? If he has anything that we are creating new, I can use Lambda. But if he already has something
that's creating, you can use Lambda, but understand the Lambda is best suited for event-driven architecture.
Yeah. Okay.
But if you want your piece of code to be always running, let's say, actually there is a default timeout period. If you're running a batch job that runs more than 5 minutes, Lambda is not. First of all, Lambda is not a solution for that. Okay, that is one scenario. That's a flat out. There is a technical restriction itself because you can't be running for more than 5 minutes. That's one. Number two, let's say you already have a web application, like your Spring Boot based application that's running, nice. There is no reason to change that right now. Your application architecture needs to be different, right? So there's no reason to change your application architecture. It's running very well. In that case, I want to do it EC2. I must do it in EC2 because moving from a code base from EC2 to Lambda is
difficult because it's complex.
Changing the application architecture now, right? Yeah. Because you're thinking now in a function, right? And you have a big monolith sitting in a web application somewhere. So it's a paradigm shift, right? So think in that terms, if your function, think of it, when any events, okay, hey, nightly, when something happens, it doesn't have to be nightly, but when somebody does something like this, I get PDFs, every time a PDF is loaded here, this is what I'm doing, okay? Then the first thing that should come to your mind is, should be Lambda, okay? And I have unpredictable load patterns. Okay, I don't know. Sometimes I get 10,000 requests per second. Sometimes I get 5 requests per second. Maintaining an EC2 instance for that is, yeah, you can do EC2 with auto scaling group and all, but Lambda is an option there with an API gateway. Does it make sense?
Yeah.
So
it depends on. So when you're architecting, you need to understand how much is the workload that we are putting on each thing, right?
Yeah.
When we are designing it.
Yeah, it's a multiple things, right? Well,
Okay.
one, just because we have a big, just because I have a hammer, I shouldn't start looking for nails. Pretty much, a problem domain should derive my solution domain. That's my way of it. And another one, as an architect, I want you to understand it. Context is the king. Context-driven development. So that's wrong. It's not context-driven development. It's context is the king, and contextualized practice. There is a guy named Venkat Subramanian. Yeah, I don't know if you guys know. He's a professional speaker at No Fluff Just Stuff and some of other great conferences. So he says there's no such thing called best practice. There's only one thing called contextualized practice. Whatever works for you may not work for me. So look at all the angles of it as an architect. Look at the cost into consideration, your availability into consideration, security into consideration, and resilience into consideration, and your maintainability overall. Having if you end up having 200 microservices, 200 Lambda functions, probably that's a nightmare. Agree, you can quickly spin up, but maintaining it's probably a nightmare. Debugging, it's unfortunately, even with X-ray, it's a nightmare. So take all of those things into consideration, and then okay.
Sure. If I deviated, I'm sorry, but I had.
Oh no. This is a great conversation. This is where I think you'll pull more information from me. It's the real live examples. Yeah, I love it. So if those are the questions, right? If you didn't read about it, please go read that Solid Design Principles. Clean Code. If you guys any coders, Clean Code is one of the best books that you all should read. Clean Architecture book by the same guy, Uncle Bob. His real name is Robert C. Martin. He's a great speaker. Is my favorite. Yeah. So my original point is, so I want you to create at least 5-6 Lambda functions and do something useful with it, not just hello world examples, like how we are talking about, the weather service here. Okay. So speaking of, just now we had a good conversation on single responsibility principle and all, right? So we should have 2 Lambdas essentially, right? One Lambda is for weather data update. So this Lambda function is essentially called, invoked when new data file, CSV file, is uploaded into S3 bucket, right? And this is the triggering point for this guy. And the functionality is parses the CSV file and updates the data in database. Agree? This is your first Lambda. Lambda function 1, weather data update. Yeah. Or is there a better name for that? I think that's fine. Now, Lambda function 2 is weather service. This is going to be invoked by API gateway. We didn't talk about API gateway. We'll talk about it tomorrow. Invoked by API gateway when clients are requesting, when clients are making an API call, when clients make RESTful API call, right? What's the functionality of this weather service? It returns weather data by zip code for a given zip code. Yeah. Right. So yeah, this is how we'll have it. And now the point is that we have two Lambda functions, and now we are defining kind of a architecture here, right? So two Lambda functions, and now I'll talk to you API gateway so that you'll be able to finish this one. At least this one you can do it definitely after playing a few Hello Worlds with both Node.js and Java. And people who are not familiar with Java, don't worry. You can do it with Node.js. It's a simple play with it with the Hello World. These two, right? Now the third one is Lambda function weather service. Now incorporating this API into your website. This one, I'll leave it to you guys. This is a static website in S3. You can do this like a Angular based, your Angular based web app. Do this one and deploy it into S3 as a static website. Okay, there. So Angular based web app. Essentially deploy a static Angular web app to S3. Deploy this guy to S3 and provide a link to get the provide a text box to enter zip code and click on a button. Yeah. When clicked on button, it calls API gateway and passes zip code. API gateway internally calls API gateway, invokes Lambda 2 to get the weather data. Love it, guys? Are you guys loving it? So you have your Angular based going to, when you click on it, it's going to API gateway. API gateway, which is triggering Lambda. Lambda is going to your RDS to get the data. Make sense, guys?
Yes, Venkat.
This is not fancy. I mean, you kind of, you know, it's a serverless web app. It's a serverless web app. Yeah, it's a serverless web app, and both static and dynamic content there. I know it's a simple use case, but it's it explains all the components pretty easily. Yeah. Okay. So that is the idea. That's the idea between today and tomorrow. So I'll talk about this concept. This concept is pretty straightforward. I can tell you that. But can we focus on, you know, these two? Can we do that? And this kind of will give you a refreshing thought that, like, how do we create RDS again and create the table? How do we, again, your security groups, all of that. So one thing I want you to understand is when you create your database, expose the database port 3306 to everyone okay. Okay, it's not the best practice. You can do something called database proxy. You can create a database proxy, okay? Or to keep it simple for now, expose the port to everybody, you know, one way or the other. That's one thing, yeah, I want you to keep in mind. Can you guys
the
do
Lambda function too, we can only do it after we know what's the API gateway, right?
That's a good point. No, what I will say is, can you create a Lambda function? I will give you a zip code. Okay, how you get the zip code? API gateway will pass it. How you get the zip code? Don't worry about it. Hard code the zip code, but everything else you do it. Does it make sense or no?
Yeah. Okay.
So the zip code will be passed by API gateway as part of the event. Okay. So that we will worry about that. So what you can do is you assume that you have a zip code. Or you don't need to assume, you know, pass it as part of your input, your event, right? It's a simple. Agree with that? So, and then go to the database, get the data and expose it, all of that, do it. Plumbing, we will do it tomorrow. Make sense, guys? Okay. Let me start recording.